Okay, everyone, thanks for coming up with this quick lecture on now here we are, unlike the other one I said we were, that was the GLM function. But before we go to the GLM function, we're just going to keep it with the regular function of LM. You are suing a department. Did you know that? For sexual discrimination. But let's look at the large N study. So here we have annual salary. All you do for the quizzes is copy and paste it. So you just come here, copy that sucker, and then paste it here. Pretty easy, right? So you just want to say annual salary. I'll just call it annual because the numbers, if when you create a vector, cannot be separated. So let's check this out. C is combined. We're going to combine all those and make the annual salary, right? This is similar what we will do with the GLM, because I always finish up with the LM function. That's just linear modeling. And you can use the LM function, remember, as long as you have a dependent variable, that is the result, which is this annual salary, is a continuous variable. The thing about the independent variable, it can be, let me repeat, it can be a nominal categorical variable. That's like male, female, religion, any type of thing that's just like categorical, not necessarily numerical. So annual we have here. So let's see if it pops up. And right there, you'll see it did. And you created it. See, and now you can create like a CSV file, an Excel file, that is, and you can find numbers from anything. Now these have to be in quotes. That's the thing, and I always do it. So I wrote sex because I did gender before this. All right, copy paste, boom, paste. Now you want to watch out for what you call these, because if you keep on calling it gender, I gets confused. I was like a person, it gets very confused. So they have to be in quotes. So like if you do countries, if you do any kind of thing, they have to be in quote. And you can see, and it did come up. You just see it there with the 3-letter rule. You put in 3 letters, etc. Just pops up. So let's do this. So we're going to talk about, this is about annual salary. So we're going to call this dinero. So you basically what you're making. So this is basically the LM function. And you ask yourself, what's the independent variable? The independent variable, that's the causal variable, is gender, right? So, but in this case, we called it sex. Boom, boom, that's the independent. But remember, the dependent variable always comes first, and that is annual salary, right? So I just say annual, and how you doing? And then Tia tilde. Now notice there is no name to put in there, data equals, etc. So look at, it was that easy. So you're a lawyer and you want to come up to a summary, right? And you want to say, okay, what's the what's my case, because maybe Marsha wasn't the best worker, that's why she's making less money. But if there's a relationship between gender and income, that is annual salary, then that means there could be discrimination in this case. So this is important for like law, policy, just understanding the world, large N data sets. So let's take a look at what we get with dinero. You could do this with a race, right? So you're not getting any significant difference. It seems pretty solid there. That's a very high p-value. Look at the multiple r squared. So how do we read this? Well, the estimate is basically our practical value on how much on average men are making. It seems like they're making more, but we're going to relevel it to see. Standard error is essentially asking you, if you did this again and again in different samples, around how much of an error would you get? And that seems to be 30,000, which seems like you would get a big error. The t-value, which gives us our p-value, and also our standard error, is very low. It's not even a point, it's 0.713. The t-value, the bigger the better, because that means there's a spread with the independent variable, which the independent variable would be causing movement, and it's not. And then you basically have a very high p-value. Remember, the p-value below 0.05 is significant. That's against the null. That's like saying, it's not happening because it's so low, below 0.055%, when the null is true. So in order for it to be true, that is, in order for the independent variable to be moving it, you need a very low p-value. So the p-value actually is against the null. That gets kind of convoluted. So with a higher p-value, just remember this, with a higher p-value, you're not getting a relationship between the independent and dependent variable. It's not strongly suggested by this model. So if you get a low p-value, it's not happening under 5% of the time when the null is true. It's basically a very, very low chance, and you need the independent variable to see that dependent variable. In this case, gender is the independent variable. Annual salary is the dependent variable. That is, the independent variable gender is making the dependent variable annual salary move. In this case, it is not. I repeat, it is not. And so there is no real, according to this algorithm, significant relationship, statistically speaking. We also can use, right? We've got all those kind of match. This matches as well, the R squared. That's how much our model is explaining, right? This relationship, and it's not. You remember, closer to 1, that is a straight 1, is better, and that's 0.04. Let's just say 0.5, round it off, 0.05. So what do you need to take away from this, right? Under 0.05 with the p-value, that's the p-value. Under 0.05, it would be considered significant that there is a relationship between these variables. Then you look at the multiple, the R squared. Anything closer to 1, the closer the better for your model. So your model, this is telling us how much our model is explaining this relationship, and it's not. So you would conclude that, hey, there seems to be no significant relationship between gender and income. So if you're a corporate lawyer, you're defending the corporation here, you'd see that? There's no relationship. So this is important for law, policy, general information. But it does seem to be that men are making more. So you could make that as a practical value. So you could say, yeah, it might not be statistically significant, but it looks like. But let's re-level it. As you know, R and all these other Python, etc., have classes. So you have to ask yourself, what class, right, is sex? Okay, sex is character. We got to turn it into a factor in order to re-level it. So we're going to take this male, right, and make it the base, and then female up here, just to do another test. Now, why is female first? Is it because females are first? In our studio say, oh, females are first. Absolutely not. A, B, C, D, E, F. F becomes before M in the alphabet. So it depends on where you are in the alphabet. And you can use this LM function, like I said, even though we have a categorical variable for the independent variable, we still have continuous. And you'll see that in the other ones. But I wanted to do this just to make sure you understand, because this is how it is on the quiz. You'll copy and paste these. Okay, so let's do this. Let's make it into a factor. So we're doing sex, just like we'll do gender when we do GLM. Now let's take a look at this sex as factor. Do sex again. Boom. Now you do not have to do the step of class. All you have to do is sex as factor, sex, and then it turns in. I'm just checking to make sure it went through, because this is just asking what class is it. So now it's a factor. So now we can say sex and re-level it like we did in the other videos. And re-leveling it will make the male the base and the female not the base. Here, let me make this bigger. So this is going to switch this base right here. So then we're going to say, okay, let's go for re-level. No packages are needed for the C. It's just the regular R default. So let's take a look. What we're going to do, sex. Now we're going to put it, how is it male? M-A-L-E. Remember, look at, it's not space sensitive, but R is very, very, you know, if you capitalize it or not, it's very sensitive that way. It's sensitive, you need the comma. But let's take a look. All right, now we're going to look at this and see if it works. So notice that space didn't matter, but the quotes, these parentheses. Remember, when you're coding and you do long codes, it's broken up into parentheses. And this is good practice if you want to do Python, etc. You just want to understand large statistics. Remember, this is just helping people with the analytical skills, but I do want you running some R so you can write it on your resume, curriculum vitae, etc. And this is like advanced analytical skills, right? Because anyone can say, hey, I didn't get a promotion because I'm male, female, etc. But let's see the large end study. So then I'm getting a low salary, etc. Because I run different models on these things. So let's take a look at this. So let's do this again. What did I call? I'll call dinero 2. Dinero number 2. Dos. Look at that. Dos is 2. Did you know that? See, you're learning things from the class, not just that. All right. And we're basically doing annual salary is the dependent variable. That is the result, and see if sex, that is gender, but I use it too much, is going to be, let's take a look. Summary. Ooh, I always get lost what I do. Just, there we go. Then it pops up there, so it's easier for me. Dinero 2. You ready? Boom, and there it is. You look at sex female. So look at that. That's an interesting practical value. So even though it's not significantly significant, statistically speaking, you could still say women are making, on average, these, negative $21,000. So that's like really, really bad. It's like you could basically say, look at, even though women are not doing, are it's not statistically significant. It seems that women are unfortunately making less money. And I think that this becomes problematic because you basically have this idea that, even though it's not statistically significant, there seems to be something going on here. So what you could do really quick is, let me get Plotly out of here, and I'll just use the affairs one that I have. Remember, Plotly is a package. You have to install it first. That's with the quotes, and then get it out of the library. But I just copied and pasted ggplot affairs. So, but there is no name here. So what you would just want to do is plus. Now it's not our independent variable here is sex, so it should pop up. And then number of affairs, we're just going to do quick, is annual salary. Let's take a look. And then we're going to fill with sex. And then I'll go over that thing after. So, no, what does that mean? Boop, boop, boop. Sometimes it doesn't always work. So let's see, X equals sex, Y equals annual. I'm getting a null for this. Did I do my Plotly correctly? Let's take, I see. Sorry about that. It's not running. I got to get my Plotly up in order. Hold on. Yeah, so basically I did get it. Let me show you, because as you can see on the side, let me cut and paste it. Check this out. So what this tells you here, I was putting the annual here. I guess you could fill it because the other data said I filled it with something else, but I want to show you exactly what I did because you can make it in two sides. So I just jumped into ggplotly here. So stat identity means they're basically side by side. So this was not statistically significant as we saw early on. But what's those things when you go like this, watch. So anyways, but then you could just bump up and then you go back, which I'm going to change this. So even if you were, let's say the corporate lawyer said, okay, there is no statistical significance, you can still come back and say, but there's a practical significant look at. Even though, according to the algorithm, which is interesting, women are not statistically speaking, not making less. If you look at this just basic graph by ggplot, it does seem to be something is going on here. Ignore that. I can change that later. But this is called the legend. So the legend is basically telling us, where you look at the numbers, but men are kind of making a little more. It might not be statistically significant. That's kind of difficult to say, but something's going on here. And what? So check it out. Let's now change this. So you could also switch this around depending on how you like your things. Now, these colors automatically come up. I'm not sure why that's the default, but you could actually do it like this. Watch. And then we essentially have this type of model. Goes over there. So there you go. That's the LM function. Sorry, my mic here. That's the LM function. And what we're doing is we're running basic regression using categorical independent variables on this. And you're basically seeing it's not statistically significant. However, at the same time, right, you basically can make a graph, and that does show something is happening. So you could use that in your court case. You could use this in your thesis. You could use this in, dissertation. You can use this kind of thinking. Even if you could care less about statistics, you could use this in you could use these graphs in any kind of interesting study. So you literally could wow your professors, wow whoever you end up working for, etc., and say, oh, I did this, research. Let's say the Arizona legislature or something like that, and look at what I have for a graph. And it's very easy. I just use ggplotly, ggplot. There is no name to put here. If I had the affairs, I'd put affairs. And then there's the aesthetics, annual, sex, depending on how you want these to go. And then I'm filling it with the annual. That means you're filling it with something, and that's the annual. That's what I got. Flushed it on, and then GM bar. This is the bar. This is not a linear regression where we use GM point, but that's really interesting. You could take any kind of thing, religion, race, incarceration. Let's say you're doing a research on prison, so you just want to use this ggplot and say, okay, I want to put in how many people are going into prison. So it would be a lot more than this, because it would have, say white, African American, Latino, you get the picture, Asian, etc. What is the basic numbers? And this can tell you something here by making charts. So thanks everyone for coming out. I really appreciate it, and take care.